Finally, on assignment 3, problem 8, it goes through this idea where you're at an airport and there are 24 identical looking packets of white powder that have been taken from a traveler's suitcase. It turns out that 18 out of the 24 packets are actually cocaine. The remaining um, the remaining 6 are not cocaine. Maybe they're flour or table, like powdered sugar. I don't know, whatever they are. Okay, so, and then here the actual customs officer is going to take 4 out of the 24 packets and they'll test them for cocaine. So let X be the number of packages that are actually containing cocaine. Then the options are either 0 of them, 1, 2, 3, or in fact possibly all 4 of the packages could be cocaine. There are 2 ways to do this problem. One is, now that we've talked about the hypergeometric distribution, you could perhaps identify this as a hypergeometric distribution. The key to identifying a hypergeometric distribution is to think about if the probability of success or the probability of the event that you're thinking about changes or not. So here initially, I guess the first package you would have 18 out of 24 to be your chance of it being cocaine. However, the next package, once you've already tested a package, you wouldn't throw that back in the pile. The next probability would either be 17 if the first one was cocaine out of 23, not out of 24 because you've already tested one, or perhaps it could be 6 out of 23 if you got a non-cocaine package. But the point is that either way, the first chance was 18 out of 24, and the second chance is either 17 out of 23 or 6 out of 23. Either way, it's not the same probability as 18 out of 24 repeatedly. This is different than a binomial situation, where in a binomial situation, your probability of success always remains constant. So think, for example, for a binomial situation of a dice, where you have a chance of rolling a 6. The chance of rolling a 6 on a normal 6-sided dice is 1 out of 6. And then every time you roll the dice, the probability of getting a 6 is still the same 1 out of 6. The probability does not change. That is much more like a constant probability that you would use in a binomial situation. So here, in this case, when you're trying to find the probability of how many packets of cocaine, then you could use R if you liked. Here, let me just bring R here. And I've got the command right here. So here I could say this is D hyper, where I'm trying to find the options 0 through 4, so 0, 1, 2, 3, or 4, where the number of successes is originally 18, the number of failures is 24 minus 18, and the number that I am selecting out of the 24 is 4. Then I will be given the probability of 0 out of 4, 1 out of 4, 2 out of 4, 3 out of 4, or all 4 out of 4. So I'd have all of the probabilities that I'm looking for. After you find those probabilities, you can put them in. Part B is asking you about the shape of the distribution. So here in this case, you can list out the options, 0, 1, 2, 3, or all 4 out of 4 bags having cocaine, and then just think about the height of these probabilities. Okay, so just draw a line for if 0 is the smallest, draw a small line, and if then the next largest is 1, the next largest is 2, and then the next largest is 4, and the largest overall was 3, then here, once you've seen the top height, which in this particular example is 3, then you just look at which tail, so from here the tallest value to 0, or from the tallest value to 4, which tail is actually longer. In this case, this example, it does look like here the left tail is longer, so this could be skewed left. And finally, to find the expected value, you have one of 2 options. Either you do each option times by its probability plus each option times by its probability and so on. Or if you have recognized this as a hypergeometric, you can go right to the formulas for hypergeometric and find out what the expected value and the standard deviation are from there.